here's a fun integral, and we're going to master a lot of tricks along the way in calculating this integral, and I'm a professional mathematician. I'm going to show you how to think about this. So we have the integral of arcsin x over x squared dx. Now one of the first things I like to do, especially when I see an arcsin x in an integral where you have the advantage of u-substitution, is to do a substitution to get rid of the inverse sine function, which is a bit unwieldy. Okay, you don't have to do it. There's alternate approaches, and I want to hear from you what approach you take. If you drop a comment down below, but I'm going to show you my approach. So the first step is just to take u equals to arcsin x, or another way of writing it out, which is nice, and I'll explain why, is to write out as sine u is equal to x. Okay, so we're putting a substitution x equals sine u instead of thinking of it as u is a function of x. And why this is helpful is if we differentiate both sides with respect to x, we're going to get cosine of u du is going to equal to dx. And what's advantageous about this is that now we can replace the dx directly in terms of u and du, without having to look for something in front of the dx. You know, when you do u-substitutions, you look at something times dx that you try to recreate with the du. Here we don't have to do that if we write x as a function of u. So we've got cosine u du is dx. We can just straight substitute. So we get the integral of x squared is going to be sine squared u. Arcsine of x is going to be u. Okay, so we get u over sine squared u, of course, times dx, which is cosine u du. Okay, so don't forget the cosine u du. But now what do we do? Okay, we've got rid of the arcsine, which makes this something which could be susceptible to standard techniques. Always in math, remember that if you can do a step and the problem looks more simple, then you've made progress. Okay, you're always going in the right direction. Okay, so always believe that you can make this next step afterwards, because once you see this, you know it's just usual trig functions, and you've probably practiced a lot with that. So we've got u cosine u by sine squared u. So how do we handle this? So here we're going to use another integration technique, and it's a pretty important one, but it's sometimes considered quite complicated. I'm going to break it down for you very intuitively, and it's integration by parts. Now before that scares you, what we're trying to do here with integration by parts is, I'll explain why in a second. If there is something where differentiating that thing and integrating the remainder of the integral could make it simpler, then we should do that. Now in this integral you have a u. If you did not have a u, the integral would be doable. It would be cos u over sine squared u, which looks like a substitution. You can substitute v equals sine u and get the dv on top. But because you have the u, you can't quite do that. So what helps, or if you try to do that, you'd get back to your original integral. So what helps is to do an integration by parts, which allows you to differentiate some part of it, which could simplify the integral, and you have to integrate the cos u over sine squared u, which could make it more complicated. But at least differentiating the u will make it simpler, it'll get rid of it, and that might make things easier for our purposes. Now how that actually works, it's worth just recalling, is basically integration by parts, a product of two functions a and b. We have integral of the derivative of ab, which is going to equal to the integral of a prime b plus the integral of ab prime. Okay, just the product rule. Integration by parts is the reverse of the product rule, just like integration is the inverse of differentiation. So then we're just going to get that ab minus the integral of a prime b is going to be the integral of ab prime. Now what's happening here, as I said, is in this case we're seeing this integral and we want to simplify it. So what we're thinking of is by differentiating the a and integrating the b prime, in other words replacing it with b, we're just reduced to calculating this integral, which could be simpler for us. And then of course ab is not an integral, so we can just plug that in and we can solve for the original integral. So what we're going to do is we're going to write our a and b prime. Okay, we don't know our a and b yet, but we're going to write our a and b prime. Our a is going to equal to u, and our b prime is going to equal to cosine u divided by sine squared u. What this is it's writing out our u cos u by sine squared u in terms of integral of ab prime. Okay, and now we want to simplify it, hopefully, by taking a prime b instead of ab prime. So what does that look like? A prime is just going to equal to 1. Everything is derivatives with respect to u, because that's our variable of integration now. And then our b is going to be the integral of cos u over sine squared u. So what is the integral of cos u over sine squared u? It's the integral of b prime. What's the integral of cos u over sine squared u du? Well, basically you can do a substitution. So I just like to say, okay, let v equals to sine u. And as I said, that's the integral that was more doable for us. Okay, so v equals sine u, therefore dv equals cos u du. And now we're just going to get, b is going to be the integral of Cos u du is up top. You see the derivative of sine up top, so you know the substitution will be v equals sine u. And then what you can do is you can write this as dv divided by sine squared u, which is v squared. Okay, and dv over v squared, okay, this is the integral of v to the negative 2. So you raise the power by 1, v to the negative 1 divided by negative 1. Okay, so it's going to be negative 1 over v, and negative 1 over v is negative 1 over sine u. Okay, so I've just done that in 2 steps, but that's what we're going to get for our integral. Okay, so now using integration by parts, we know that this is the integral of ab prime. A was u, b was cos u by sine squared u. So we've got the ab prime, so it's going to be ab, so ab is u times negative 1 over sine u, so it's going to be negative u over sine u, and then we're going to subtract off the integral of a prime b. So a prime b is 1 times negative 1 over sine u. Okay, so it's going to be negative of 1 times negative 1 over sine u, which is just going to be negative 1 over sine u du. Okay, that's going to be our integral. So we've gotten pretty far now. Okay, we've gotten pretty far because now we just have to integrate this, which is a whole lot simpler. Every time we've simplified one step, we know we are in a doable situation, we've made progress. So now I'm going to finalize this, and it's going to be subtle, okay? So you want to watch till the end because I'm going to have to do some tricks here to make this really nice. All right, so let's now write this out. This is going to be negative u over sine u, and we're going to now add on the integral of cosecant u. Okay, cosecant u du. Now, there's a trick for finding out the integral of cosecant u, so I'll not do it in this video, but I recommend, you just practice this out if you're unfamiliar with it, but the idea is to multiply top and bottom by cosecant u plus cotangent u. Okay, it's quite a, weird trick, but it works. Then you can sort of see a substitution, and it's going to be minus u over sine u, and it's going to be plus log of the absolute value of cosecant u minus cotangent u. Okay, and everything is of course plus a constant, but we'll get to the constant at the end. So how do we simplify this? So remember that u was arcsine x. Okay, so u was arcsine x. So then we can now write this as u over sine u. Sine u was x. Okay, so it's going to be minus of arcsine x divided by x. Okay, that's number 1. And then we're going to have something interesting here. We're going to have log of 1 over the sine of u minus cos u over the sine of u, okay, all in absolute value. Now we know again, u was arcsine x, so sine u was x. So since I'm repeating that a few times, I'm just going to actually box this out here, that u was the arcsine of x, and therefore sine of u was going to equal to x. Okay, so just to kind of see what's happening, so you can now kind of see the 1 over sine u what's going to happen, and you know the sine u what's going to happen. What about cosine u? That's where we're going to have to do a trick. Cosine u is cosine of arcsine x. So what's going on there? So the way I like to think about that, and I'm going to do another little box here, is cosine of arcsine x. So we know that cosine of anything, okay, cosine of u is the square root of 1 minus sine squared u. Okay, that is a trig identity, that cosine squared plus sine squared is 1. And then we know that because sine of u is going to equal to x, this is going to be the root of 1 minus x squared. So now we're in a pretty good position. We can finalize our integral. It's going to be negative arcsine x over x plus the logarithm of the absolute value of 1 over sine u, which is 1 over x, minus cosine u, which is root 1 minus x squared divided by x. Okay, so that's going to be our final integral plus a constant. Don't forget the plus c. And that's our answer. So pretty cool, right? And as a fun exercise, if you like, just to practice, try to differentiate this and see that you actually get back arcsine x over x squared. Pretty fun. I hope you loved that integral. I had so much fun doing it. Now, if you want more integrals, I have math at all levels on my channel. Advanced proof-based math, beginner math, graduate level math, everything. But I have a lot of integration. So if you want to check all that out, check out the playlist. It's going to pop up on the screen here. It's going to direct you to a video, but there's a whole lot of other videos in that playlist. And if you're loving my content, please don't forget to leave a like and subscribe. Thank you so much for watching so far. And finally, there's one more video for you. You're going to love it. It's a bit different. It's going to be on a proof that two numbers chosen at random, they're relatively prime. The probability is 6 over pi squared. It's a fun little thing. It's related to calculus. You're going to love it. So check it out here. It's going to pop up on the screen. And I'm super excited to see you in either of those. Have an amazing day, and I'll catch you later.